In this video, we'll be looking at how to solve problems with operations of rational numbers. So the first thing we want to do before we get into the word problem solving of itself is to review some of these keywords that each of our operation symbols mean. So whenever we need to add, we may hear words that are all listed below here. Whenever we need to subtract, we may see these words. When we multiply, we'll see these words below, and when we divide, we will see these. Take a minute to pause and review them in case you want to go over those on your own. Now that you've reviewed what those words mean, we're going to practice on changing these verbal expressions into algebraic expressions. So we're taking them from words into numbers. So what I like to do is read the sentence and write the symbol above each of the keywords. So it says 4 increased by 12, and when we increase, we add. So I'm going to say 4 increased by 12, and if I add that, that would all be equal to 16. My next example says that 3 is being decreased by 9. When we decrease, we are subtracting. It's getting smaller. So I start with 3. It's being decreased, so we subtract 9 from it. So if I had 3 minus 9, or 3 decreased by 9, I would end up with negative 6. My next example says twice. Twice means 2 times something. And then it says 40. So the next keyword that we have is. Whenever we hear the word is, it means equals. So we're going to set this up as twice 40, so 2 times 40 is or equals 80. And 2 times 40 does equal 80, so that is a true statement. And finally, we have the quotient of 6 and 3 less 1. So the quotient means we're dividing. And whenever we see quotient, we write it in the order that it comes in. So when I see the quotient of 6 and 3, that means I'm doing 6 divided by 3. You could also write it as 6 over 3. The next part of this says less 1, so we're taking 1 away. So I can either finish this statement by saying 6 divided by 3 minus 1, or like this. And remember that if you were going to then go solve that, we need to follow the order of operations. And since we don't have any groupings or any exponents, we skip those first 2 steps, but we do have some multiplication or division. We've got division here, so 6 divided by 3 is 2, and then we can subtract, because addition and subtraction come at the very end, so 2 minus 1 is 1, and we would ultimately get an answer of 1 there. So just keep in mind those keywords and your order of operations when you get into solving these rational number problems. So before we solve a problem, we're so close, we need to learn those steps for problem solving. So you always want to follow these steps while you're doing these. First, start by reading the problem. Then make sense of what the problem even is talking about and what they're asking you to solve for. Usually those keywords can help you determine what operation to use, but you need to know what the problem is looking for in its answer. It's helpful to underline keywords and cross out information that isn't important. Those keywords are going to help us decide what operation to use. Then we will solve the problem by showing our work and following the order of operations, or GEMDAS. And then we're going to check our answer and ask ourselves if it makes sense. Is this a reasonable number? Does it make sense for the scenario that I'm in? So now we're going to go into these examples. And I'm sure that you can pause the video and try some of these on your own, but make sure that once you pause them, that you're listening back to hear kind of how we went through this and what steps to follow. So in the first example, it says the temperature in the desert was 160 degrees Fahrenheit on Tuesday and negative 22 degrees Fahrenheit overnight. What is the difference in temperatures between day and night? So we went all the way from, imagine we're on a thermometer here. I'm at 160 degrees during the day. That is really hot. I'm going to get all the way down to negative 22 degrees at night. That's really cold. Well, in the desert, it's really drastic like that. So that makes sense here. But we want to find out what's the difference in the temperatures between the day and the night. So I want to figure out this entire distance between these two numbers. Well, thinking about a thermometer, it's kind of like a vertical number line. So if you want to redraw it on the number line, I'm trying to figure out how far did I go to get from negative 22 all the way up to 160. Well, a little bit past negative 22 on this number line is going to come 0. And then we're going to go all the way up to 160 here. So what I like to think about here is that this distance here, this blue distance, is from negative 22 to 0. Well, that's 22 degrees. This distance from 0 to to 160 would be 160 degrees. So that entire distance between negative 22 and 160 would just be adding the blue and the green parts there. So I'm going to add these together, which means I'm 182 degrees apart. That is the difference between those two temperatures. Now, if you want to use operations rather than trying to draw the number line here, we can use that keyword difference to help us. The original temperature was 160 degrees. The next temperature was negative 22. To find the difference, we subtract two numbers. So I'm subtracting a negative. Well, whenever we subtract a negative, the opposite of a negative is a positive. So this really turns into 160 plus 22, and we get a total difference of 182 degrees again. Either method will work here while you're solving these types of problems. In question number 2, it says Allie plans to go skydiving over the Grand Canyon. She will drop from the airplane at an altitude of 12,000 feet. She plans to land in the canyon around Bright Angel Campground, where her elevation will be 4,380 feet below sea level. So how much distance will Allie cover during her jump? Well, again, here it's really helpful if we draw a picture. So I'm going to draw the canyon here, and we're going to say that sea level, that's our neutral level, is at 0 feet. She's jumping all the way from up here in an airplane. She's skydiving, and her elevation to start is at 12,000 feet. So she is already starting from all the way up here, and that's a positive 12,000, so I don't want to put that minus in front of it. And then she ends up at her campground. Her little tent might be set up down here, and she's going to end up at negative 4,380 feet below sea level. And they asked, how much distance will Allie cover during her jump? So it's kind of similar to that temperature problem we just did. We're trying to figure out, she went all the way from up here at 12,000 feet above, and she made it to the surface or the sea level at 0 feet. But because it's a canyon, it's open below the sea level, and she had to go another 4,380 feet to get down all the way to where she landed. So that means, if we want to kind of color code this again, that this part where she's jumping from the sky just to sea level is going to be from 0 to 12,000. Well, that's 12,000 feet away. And then she's going from 0 all the way down to negative 4,380. Well, that's 4,380 feet away because we're talking about distance, so it's the positive version of it. So all I'm going to do here to get this entire distance between where she jumped and where she landed is take that 12,000 feet and add it to the 4,380 feet. And when I do that, if you want to stack it vertically and add that, you can. I end up getting 16,380 feet is how much she traveled. Now again, if you want to write this algebraically, she started at 12,000 feet. We are finding the difference between these two numbers because it's the distance of how far apart are they. So we're doing the difference, which is subtraction, between that and negative 4,380. And remember, we are subtracting a negative, so taking the opposite of a negative means add those two numbers, and that's why I'm ending up adding them when I do it in the picture form, and I still end up with that same exact number of 6,380 feet is how far she traveled from her airplane down to the ground while she was skydiving. In question number 3, it says a taxi charges $8 per ride plus 35 cents for each mile driven. If Becky needs to go 10 miles, how much money will her taxi cost? So they tell us $8 per ride plus 35 cents for each mile driven. She needs to go 10 miles, and how much money will her taxi cost? There's a lot of information given in this, and so I want to kind of just break this down into, ultimately, the cost is coming from the ride plus the distance that they're charging you. So right away, the taxi is going to charge $8 for Becky's taxi ride, no matter what. Doesn't matter how far she's gone, but they are going to first charge her $8. Plus, they gave us that keyword plus, they're charging her for 35 cents for each mile driven. Well, it's 35 cents, and each means we multiply, because every time she goes another mile, we're basically adding another 35 cents. Well, if you're adding the same number repeatedly, that's just multiplying it. So now my problem now becomes 8 plus 35 hundredths times 10. And so what we need to do here is focus on the order of operations. We don't have any groupings, we don't have any exponents, but we do have multiplication or division. We need to do our multiplication problem first. My multiplication problem is 35 cents times 10. To multiply these two numbers, I can use this multiplication method. When I add them together, I need to take my decimal and move it 2 places over. So that means that 35 cents times 10 means that she's paying $3.50 for those 10 miles that she's going in the taxi. Plus, she still has to pay that original fee for the taxi ride. So now our last step is just to add the $8 plus the $3.50. So I can then add these by aligning their place values. And when I do that, I end up getting $11.50 as her total. So that means that Becky will pay $11.50 to take a taxi 10 miles at this rate. And finally, in the last question, it says Kevin is playing a trivia game on his phone. For every correct answer, Kevin earns a half a point. For every incorrect answer, Kevin will earn negative 1/4 of a point. If Kevin has 16 correct answers and 8 incorrect answers, then how many points does he have? So notice right away I started color coding this as I was reading it. This is going to help us break this question down. I want to figure out, okay, if he got all these numbers correct, how many points does he get for being right? But then he also got some wrong. So how much is he going to lose for getting that much wrong? And we're going to put that all together at the end. So to figure out Kevin's correct answers, they tell us that he earns a half a point for each one. And for each question, he had 16 answers correct. So he gets 16 half points. Well, if he has half a point for 16 answers, that's 1/2 times 16, or just half of 16. So you can ask yourself, well, what is half of 16? I know that problem. Half of 16 would just be 8. Now, mathematically, the way that that works is, well, 16 is a whole number. We can write any whole number over 1. And remember, when we multiply fractions, we multiply across the numerator and across the denominator. So 1 times 16 is 16, and 2 times 1 is 2. A fraction is just a division problem, so now all I have to ask is 16 divided by 2, which is 8. So that means Kevin has earned 8 whole points just for getting all those questions right. But now he also has some incorrect answers, and every time he gets a question incorrect, he loses a 1/4 of a point. So he's getting negative 1/4 for 8 incorrect answers. So you're kind of asking yourself two things here. This is a negative times a positive. A negative times a positive is automatically going to be negative, and this makes sense because he's losing points when he gets things wrong. So our answer needs to be negative there. But now I just want to say, okay, I want 1/4 of 8. Well, I need to figure out if I split 8 up into 4 pieces, how much would each of those pieces be? So I can say, well, that would be 2. But let's check it. 8 can be written as 8 over 1 because it's a whole number. And then I have to just multiply it across the numerator and across the denominator. So negative 1 times 8 is negative 8. And since I already used the negative sign with a negative 1, I'm just using the positive 4 here. So 4 times 1 is 4. Now my problem becomes negative 8 divided by 4. A negative divided by a positive is a negative, and 8 divided by 4 is 2. So that's how I ended up with that negative 2. So now we are almost done. To get his total score, we have to take everything he's earned and add it to everything that he's lost. So I'm taking that positive 8 points and adding it to the negative 2 points that he lost. But think about it. If I started with 8 and I lose 2, I'm adding negative 2. That's really just subtracting. So that means that Kevin ends up with 6 total points at the end of this game.